Welcome to The Explainer. We are jumping straight into the incredibly high-stakes world of chemical manufacturing today. We're going to break down the critical standards, the rigorous tracking frameworks, and the hardcore emergency response protocols that quite literally prevent catastrophic disasters.
So, picture this. You're in a control room during a massive emergency simulation. It's incredibly tense. You've got high-tech monitoring systems blaring, tracking these wildly soaring pressure levels, alarms are flashing everywhere, and operators are forced to make literal split-second decisions. Well, outside of a simulation, that's just a regular Tuesday for a lot of chemical processing facilities. It's an environment where a single, tiny technical failure or just a momentary lapse in judgment can spell absolute disaster. So how do we actually prevent the unthinkable from happening in such a volatile space?
To really understand the solution, we've got to respect the scale of the problem. The reality of chemical manufacturing is intense by its very nature. We're dealing with highly combustible substances, pushing materials to absolutely extreme temperatures, and keeping them contained under immense pressure. Because of those sheer physical realities, the margin for technical or human error is basically zero. A tiny leak or a slightly sticky pressure valve, that's not just a minor hiccup, it's a potential catalyst for a massive explosion or severe hazardous spill.
And when that zero-margin threshold actually gets crossed, the costs are just staggering. An accidental release or explosion sends shockwaves outward, causing this devastating ripple effect across the board. Obviously, there's severe harm to workers and the surrounding communities from harmful emissions. But beyond that tragic human and environmental toll, you're looking at immense operational disruptions, physical damage to massive multi-million-dollar facilities, severe reputational hits, and frankly astronomical regulatory and remediation costs. It is literally a cascading nightmare.
Okay, so let's get into how we actually stop that nightmare. To mitigate these extreme risks, the industry absolutely cannot just cross its fingers and hope for the best. Instead, it relies on these incredibly rigorous process safety management frameworks to act as a sort of invisible shield around operations. And these aren't just vague, feel-good guidelines. They're incredibly strict, quantifiable accounting standards that let companies measure, track, and actually improve their safety. Because you know the old saying, you can't manage what you don't measure. And in chemical manufacturing, you have to measure absolutely everything.
Right, so sustainability accounting standards track process safety using three distinct heavy-hitting metrics. First up, we've got the Process Safety Incidence Count, or PSIC. Next is the Process Safety Total Incident Rate, the PSTIR. And finally, the Process Safety Incident Severity Rate, or PSISR. These three indicators work together to give regulators and investors a really complete, unvarnished picture of how safely a facility is actually operating over the course of a year.
Now, importantly, companies can't just make up their own rules for these metrics. They are strictly anchored to a foundational document called ANSI/API RP754. It's a core standard set by the American National Standards Institute and the American petroleum industry. And what this does is define exactly, with zero room for misinterpretation, what constitutes a Tier 1 process safety event. Tier 1 events are the absolute worst-case scenarios, the ones we desperately need to prevent. This standard guarantees the entire industry is speaking the exact same language when they report them.
But here's the thing, just counting incidents isn't enough on its own. Let's say a massive, sprawling global chemical complex has 2 incidents, and a tiny local plant also has 2. Are they equally unsafe? Definitely not. And that's exactly why we use the Process Safety Total Incident Rate. To fairly compare facilities of totally different sizes, the raw incident count is mathematically normalized. They basically take the incident count, multiply it by 200,000, which, by the way, represents the hours worked by 100 full-time workers in a year, and then divide that by the actual total annual hours worked at that specific facility. It gives us a true apples-to-apples rate.
But wait, not all accidents are created equal, right? A minor chemical drip is miles away from a catastrophic facility fire. And that's where that third metric, the Process Safety Incident Severity Rate, really comes into play. It makes sure we aren't just blindly counting incidents, but actually weighting them mathematically based on a total severity score. It measures the true destructive impact of those Tier 1 events, so stakeholders aren't just seeing how often things go wrong, but how badly they actually go wrong.
Let's shift gears for a second and look beyond the factory walls, because the danger definitely doesn't stay locked inside a highly controlled processing plant. Millions of tons of these chemical goods are constantly on the move. They're traveling through these incredibly dynamic, complex supply chains, getting loaded onto massive container ships, pumped into rail cars, and hauled down our public highways and transport trucks. Securing that sprawling transport corridor is absolutely just as critical as securing the plant itself.
Tracking this constantly moving supply chain requires some intense regulatory oversight. I mean, a truck driver swerving or a single train car derailing can instantly turn a standard transport route into a major hazard zone. So regulators need crystal clear rules. What exactly triggers a reportable transport incident? It obviously can't just be a scratched bumper at a truck stop. The accounting standards draw very specific, hard lines in the sand for when a transport issue officially becomes an incident that absolutely must be logged.
So here's the first major threshold. Any accidental release of more than 50 kilograms or 50 liters of a classified dangerous good immediately demands an incident report. To put that in perspective, that volume is roughly the size of a standard car's gas tank. If that amount of a highly dangerous chemical spills out onto a highway or leaks in a rail yard, the alarm is instantly tripped, and all the formal reporting and remediation protocols kick in immediately.
But it's not just the highly toxic glowing green stuff we're watching. Even if the chemical goods are classified as non-dangerous, maybe it's just a relatively benign bulk polymer or some raw industrial material, a massive spill is still a massive problem. So a release exceeding 1,000 kilograms or liters of non-dangerous goods will still trigger a mandatory report. A spill of that magnitude causes huge logistical nightmares and environmental messes, completely regardless of how toxic the material actually is.
Then there's the financial tripwire. If a transport event causes more than 50,000 euros in damages, or whatever the local equivalent is, it is strictly categorized as reportable. And here's the kicker. That 50,000 euro threshold completely factors in the cost of environmental cleanup. So even if a spill is relatively tiny in volume, if it happens to leak into a highly sensitive ecosystem that costs an absolute fortune to remediate, boom, it gets flagged and reported for sure. Finally, we have to look at the real-world human and community impact. Severe disruptions will trigger an alarm no matter the spill volume or the dollar amount. If an incident out on the road causes a death, an injury needing intensive medical care, a hospital stay of a day, or even an absence from work of more than 3 days, it's reported. On top of that, if it requires emergency services to step in, forces public evacuations, or shuts down a public traffic route for over 3 hours, it crosses the line into an official reportable transport incident. Now you might be sitting there thinking, wow, that is a colossal amount of data to collect. And you'd be absolutely right. But gathering this intense mountain of process safety and transport data isn't just some bureaucratic busywork to fill out spreadsheets. It has a crucial, life-saving purpose. It is literally the key to identifying root causes and actually learning from past mistakes. We aren't counting these incidents to point fingers. We're doing it to guarantee that the exact same failure never happens twice.
Which brings us right to the operational response. Whenever there's a Tier 1 or Tier 2 safety event at a plant or any significant transport incident out in the wild, companies have to follow a really strict, logical sequence. First up, identify the root cause. Was it a physically cracked pipe, or was it a distracted driver? Second, they have to map out the full outcomes of the event. And third, and this is the absolute most critical part, they must implement and document highly specific corrective actions.
When we actually dig into these corrective actions, they usually fall into two main buckets. On one side, you have the technical fixes. This could mean upgrading failing valves, putting in automated shutoff sensors, or upgrading to far better containment vessels. On the other side, you've got the human element. This is all about rolling out enhanced, rigorous training for facility operators and the transport drivers. The ultimate goal is to engineer out the technical failures while simultaneously educating the workforce to pretty much eliminate human error. And all of this granular data ultimately feeds into the big leagues, global reporting standards. These metrics are integrated into a globally recognized framework overseen by the International Sustainability Standards Board, or ISSB, alongside SASB. Through these standardized metrics, chemical companies can transparently show their safety records, prove their disaster prevention effectiveness, and outline their corrective actions to investors all over the world. It basically forces transparency onto an industry operating in a spectacularly high-risk space. But as we wrap up this explainer, I really want to leave you with a provocative thought. We've seen how these rigorous tracking frameworks, the strict ANSI standards, the specific transport rules, and the corrective actions build this incredible invisible shield. But at the end of the day, these metrics fundamentally measure things that have already gone wrong. As our global chemical supply chains grow increasingly complex and climate change throws wild new environmental variables into the mix, we have to ask ourselves, is tracking the past actually enough to secure our future?
Are our prevention strategies and predictive technologies evolving fast enough to stop the next unthinkable disaster before the alarm even rings? Something to think about.